Okay, so now we can start really talking about defining our own classes. We actually started last time, right? By now, you can use objects any way you need to, right? Um, the idea is that we can define our own data types. If you think about English, right? Um, whichever language you speak, but you all speak English because you're here, so um, you have nouns, things, right? And then you have verbs, right? And if you're giving instructions, your instructions tend to be to use mostly those, right? And so we will use classes to define nouns and then also define the verbs that can be applied to them, their methods. If we manage to create the right classes, which may or may not happen, right? If we manage to create the right classes, then our problem becomes super simple, right? Then it's just take this and do this to it, right? Super simple. We need to come up with those classes, and that is hard. So we'll talk mostly about the syntax, but so creating classes is like creating our own vocabulary. It's computer science, but also philosophy, if you wish, which makes it really cool. But we need to distinguish between classes, which are kinds of objects, kinds of things, and individual objects or instances. For the most part, we want to be able to define generic stuff. We want to talk about people, right? And once we define what a person is or how do we look at a person, then we can go and talk about individual people. Does that idea make sense? So one is classes define the kinds of things. Classes define person or student or something like that. Whereas instances are Joe or Joan or you. Does that make sense? So for the most part, when we're, well, actually we use both, right? When we are programming, we define the classes, thinking in general terms, and then in our main or something like that, we actually instantiate those things and go do things to them, right? So you need to keep track both of the class and the instance. Does that idea make some sense? In Java, public classes need to be in a file with the same name as the class, right? So if you have a class named person, should be in a file named person.java. And by default, and Gradle will do certain things, but by default, it should be in a folder structure that maps to the package name, right? Packages allow us to group our classes. When you start doing slightly bigger things, you do want to have your packages so you can have different subsets of classes, right? Different categories of classes. And your package structure corresponds to your folder structure in Java. Does that idea make sense? So if your package is com.okaram.person, it should be in a folder called com/okaram/, right? It's now with IDEs and Gradle and stuff, you can cheat a little bit, but for the most part, that is how it should be. And so we can do different things. I will probably be creating those packages for the most part, but sometimes I cheat and I define non-public classes or static inner classes, and those cannot be in their own file, right? And so sometimes I cheat and I define a bunch of classes within the same file, just for ease of programming. And we'll see what it works, right? How it works. you define a class with the terribly surprising keyword class, C-L-A-S-S, right? Then you put the name of the class, braces, and inside the braces you define, and we tend to call these generically members. They can be member variables or member functions or methods, right? I tend to call member variables instance variables because every instance gets its own copy. So this would be one way of defining a person class, right? Class person, and then we define the variables, string, first name, last name, and I'm putting public, and we are going to see what it does, right? And age as an int, it looks almost like variables in your main or something like that, but in this case, each instance is going to have its own copy. So let's go play. I created a folder for March 13 that corresponds to, oh, I put it outside of this, so no, let me copy it here. Move, yes, refactor, do it. Okay, so now the full name of my package, right, is ksu.cs5000.spring17.march13, right? So now we can create a person class. Our IDE is nice enough to add the package declaration. Notice that it is in the right folder structure, right? And then let me create another class that I'm going to call main. And this one is just going to have our main. No, I cannot do it main, right? Public, static, void main. Here I can do person p equals new person. This creates a person, right? Let me do p1. What would this print? And what would this print? Would it print Orlando?
It will print only Orlando.
Yeah, this stuff will print something else, right? Definitely not Orlando. It will actually print null. If you don't define it, by default it is null, which is a special value which represents no object, right? Let me go change this thing. March 13 dot. So this will print Orlando and then null. And actually, let me go do. This is gonna be interesting. Let's enter presentation mode and then we'll see what happens, right? Printed Orlando and then null, right? P1 and P2 are completely separate things. Each one has their own variables. Each one has a first name, a last name, and an age.
It's not going to be the error or something.
It's not an error, right? It's still a value. It's just, if we were to do this, right? This would work if we were to do this now. This would give us an error because we are trying to call a method on the null object. So we get null pointer exception.
So it's not even an empty string?
It's not an empty string, no. We can make it an empty string, but that
Is it a string or what?
it is a string. Null is a special value that could belong to any type, right? It just represents you're not pointing anywhere.
We can't use any method?
There is nothing you can do with it other than call equal equal to compare it with null. Nothing else would work. So let's see. We could define methods, right? We could actually, let's talk about constructors. We can define a constructor which has to be executed. If we define one, then a constructor will be executed when you call new, right? So we could have a constructor that takes no arguments and sets things up. And then h equals. If we define our constructor, now this stuff will work. And now it's the empty string, so its length is 0. Null is different and horrible and dangerous. So if you can avoid using null, but sometimes it is what it is.
But for P1, it doesn't, it's just execute like for line, right?
Let's see. Yes, because this gets executed, right? So initially, P1's here,
So it has priority, right?
it's not priority, it's order. Here, P1's first name is the empty string, right? The constructor got executed on P1. P1's first name is the empty string. Then this other statement changes the value. So it prints the empty string, then a 7 and a 0 for the length. It's relatively little magic. It's just the constructor gets executed. Sorry? Cool. Now let's talk about methods, right? We could define a method, say get full name, right? On our person class. This is horrible. I may eventually leave this, but public string get full name. So we need to return a string. We could use first name plus, actually, let's do this. What does this mean? It means the current object, right? Somebody called whatever dot get full name, right? Inside a method, I can refer to that thing as this. Does that make sense? It's the object the method is being called on. And I don't actually have to write the keyword this. If I just do first name, it's the instance's first name. So with this, now I could print something like this. Actually, what would p2.getFullName return? Not null, right? Because now our constructors make empty strings. So it's the empty string plus a space plus the empty string. So it's just a space, and so this would actually print 1. Right? So good.
Don't define P1 that last name is going to be like an empty string.
Yes.
And the length is gonna be 8
Maybe. No.
if you don't define
Yeah, it's
the
gonna be
last name.
8.
Oh, if I don't define a last name, maybe. 1, 2, 3, 4, 5, 6, 7, no space 8. Yes. Oops. Almost as handsome as the other guy. Does this make sense? So we can define methods. Within a method, this represents the instance that the method is being called on, right? We could define other stuff. Okay, formal full name, this does last name, and then so this would print Bloom, comma, space, Orlando. We have talked about constructors. Now, access modifiers. By default, fields and methods in a class have package access. Other classes within the same package can access them. We can also explicitly specify private, nobody can do it. Public, everybody can do it. And protected, my subclasses can do it. We'll talk about that later when we talk about inheritance. Sorry?
Like if you give access to us only, like this class only, then it will be protected.
Yes, but it's for inheritance. It's the subclasses when you define subclasses with inheritance, which we'll see in a couple of weeks. So, what happens if I define this as, well, what happens if I define it like this? Who can access it?
We will ask you for the public state.
No, it doesn't ask me. It's not public. It is accessible by classes in the same package.
Okay.
The main class happens to be in the same package, so it works. If you defined it in a different package, it wouldn't work.
What about would inheritance make it like public though, or could you?
No, no. Protected is the one that works with inheritance. Private means it's mine, only mine. I'm not sharing with anybody. So if I define something private, it's going to tell me, hey, you can't use it. Yeah, 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 yeah. Make sense? Many times our methods are public, our variables tend to be private. What happens if we change this and make it private? Is this a very useful class?
You need to declare any ones inside the public.
Yes, I need to define public methods that give access to this stuff, right? Does that make sense? I could define a constructor Do I need the this in this case?
Yeah.
I do, because without it, it would refer to these guys, right? To the parameters, not to the instance variables. So in this side, I'm referencing the instance variable. In this side, I'm referencing the parameter. If it confuses you, what do you do? Keep on playing, but what else? If having things with the same name confuses you, what do you do? Change the name. Make it something else, right?
So in this method, the left ones, you're grabbing it from the private?
This
Yeah.
is not, it's the instance variable. I'm saying this object's first name, right? So yes, I'm grabbing it from the private, right? Sorta, kinda. And then I can probably eliminate this guy. I would, well, this would be mildly useful, right? I'll need to change it. So now what happens? I have a constructor. The constructor takes 3 parameters, right? This is not allowed anymore because this constructor is not passing anybody, right? It's not passing anything. Sorry? God, and you expect me to be able to spell that? Maybe? I have no clue how you spell her last name. I can't even remember who is she. She's probably pretty, but other than that, I don't remember anything. Sorry?
Pride and Prejudice.
Pride and Prejudice. No.
Atonement.
Sorry?
Atonement.
Maybe. Never mind. No, she was Batman or something like that, right?
She's from Pirates of the Caribbean, right?
Maybe. Okay. I just demonstrated my great knowledge of modern cinema. Okay. So this would still sort of kind of work, right? Let's go find that. Keira Knightley. Okay. Definitely. Keira. Yeah, she was part of the Caribbean. Yeah. Okay. That's she. She was born in 1985. So she actually is 41?
30.
31? Sounds about right. Okay. Cool. We normally want to give access to many of the fields, right? So we would define a way of getting this thing, right? By convention, it's get and then the name of the field. Notice that camel casing still works here, right? Now age, the field is lowercase a, here is uppercase a, right? Because Java conventions. And this is, I can put it, I don't have to. And I can go on main and use it, right? p2.get. Does this make sense? We sometimes, depending on the class, we may want to have setters, right? Things that change the object. So public set age, int age, and the standard stuff is this, the age. Public void. Setters return nothing and set the field, right? We could also, and everything that changes an object is called a mutator. They're dangerous. Now you're changing stuff. We could also have other other mutators. Does this make sense? We talked about methods that appear in every object, right? Which methods? ToString, right? And dot equals, right? There's actually hash code, but so let's define a ToString. How do we print ourselves if we are a person? How do we print a person? How do we create a string representation of a person? Somebody else may or may not print us, right? What do we do? We probably want to do something like this, right? Person. Something like this, right? You can come up with your own standard for. We probably want to do this to declare, to tell Java that we are supposed Nah, never mind. Well, never mind. We'll cover it next week. You don't have to, but it's a good idea for kind of enforcing. So now we can do this stuff. Does this idea make sense? You know all there is to know about creating classes. Isn't this cool? Let me mention one more thing, kind of one special class, which is called an enum, or an enumerated type, that allows us, it's basically an int, but it allows us to give names to a set of integers, and you can only have one of them. So let's actually go, this public enum, right? It's like class. Instead of class, we put the right enum, then the name, and these are the possible values. To recognize these guys, what are these guys? Cards, right? In the standard French deck, right? Your classes can use other classes as part of their data type, right? So how can we define a class? A card. What's a card? Like a poker card, right? Not Pokemon or something like that. What data does it have? A number, right? And a suit, right? So we can use int number we can make this all public. In main, we would define stuff like card C equals new card. This is how you reference the objects, right? Something like suit.club or suit.anything. Is this cool or what? What other things can we define? We are going too fast. We should add more stuff per week. No. We cannot define decks because we haven't talked about arrays yet. Let's come up with other examples. We are going to sell stuff. We're going to represent a book. How would we represent it? Right, a book for a store, right? So we are not going to represent its actual contents or anything like that. How would we represent it? Okay, what's his name? What type? String? Should we call it title? Just more specific. Okay, for now let's agree on that. What other things do they?
Year,
Price.
published.
Publication.
Price. Float, right? Int publication year. Is that publication name? What is that? Sorry.
The publisher.
Publisher. Depends on, right? If you're going to put this into a database or something like that, right? Then a book may belong to a category or many. So who knows? But let me call it a string category. Depends on what are you defining, right?
So
Yes.
when we are not gonna write public or string publisher.
We will. Actually, why are you suggesting horrible things? Maybe even.
What if the price is not floating number?
What would it be?
Like $20?
So,
That's okay. $20 is a floating point number.
yeah. Price always floating.
Right? I mean,
For New York, you don't sell as a Georgia.
oh no, he would like int versus float. I think that's what, and int is also a float, right? I mean, in math, not in programming, but right. If it happens to be a whole int, you still represent it as a float, representing that whole int. Floats are actually horrible for prices, but we could actually use something like big decimal, which Java allows, which is better because now we can have cents, whereas floating points may or may not. But in main, we would use this kind of stuff with did I eliminate the title? No, right? God. What book? What? Oh, yeah. Chamber of Secrets? Was it one? Thank you. Then you can go find the other stuff. I have no clue what's the year of publication or something like that. It's probably about 20 years ago, right? Let's go to the fountain of all knowledge. $1997? Oh, the first one is
Chamber of Secrets.
yeah, Chamber of Secrets is 2. So Harry Potter and the Philosopher's Stone. That's the first one. This is this. Oh, and yeah, if you were storing this in a database, right, you would also do something like the ISBN or something like that, right? What else would be a good example?
Is the big decimal correct?
Yeah.
Should it start with small b?
No, it starts with, this is a type. This is a class that Java defined for us. Oh, one thing we haven't talked about is the static modifier, right? The static modifier is for variables. This variable doesn't belong to each instance, but there's only one for the whole class. Belongs to the class, not to the instance. Does that make sense? So if in here, in my constructor, I increment it, actually, I am horrible. I'm a horrible person. Int. This, right, is not mine, it's the whole class. So in main, if I define this, what am I gonna get printed? Right? Because it's the same guy. If I remove this, what would I get? 1, right? Because each one of them increments its own thing. Does that make sense? Well, actually, well, yeah. Do this. What happens if I declare a method being static? Basically means the method promises to never access. The method doesn't have an instance variable when it's being called. It doesn't have any this, so it can only access static variables. In this case, I don't have a static variable, so it's going to complain, right? If I made this static, might even work. Yep, it does. Maybe. Where did this end up going? Oh, it's, yeah, this guy doesn't have a name. So this guy, we have to do it. If the method is static, I can also reference it as books.getNum books without actually needing an instance at all. Does this make sense? Now you know why we have been defining all of our stuff as static. Right? Some point in time, I promise you we'll cover it. Now we did. Isn't this cool? Yes, no, maybe. Cool. Any questions on objects? No? Should we go faster and cover arrays? Why not?
Please,
Sorry?
Please, one more time, how you got this?
The book has a static variable. That means this belongs to the whole class. Every instance of the class shares the same variable. So in the constructor, I increment it. In here, I instantiate 3 books. This guy, this guy, this guy. So each one of those increments the same variable. Isn't this cool? Yeah? Yeah, we are gonna have to do it, sorry. You guys are fast, that's good. By the way, this is called encapsulation. The idea that you are putting into one unit, the class, both the data or the state, right, the instance variables, and the behavior, the method. Now, yeah. The only bad thing is that you have assignment 7 and 8 due this week, this Sunday. But that allows us to spend more time doing fun stuff, right? We can talk about arrays. Arrays are bunches of things, right? When we program, we tend to want to define a bunch of things. A bunch of things is an array. All the things have to be of the same size, the same type. So an array is a fixed type collection of objects. All of the same type, sorry. Arrays don't grow. They have a fixed size when you create the array. They have a property called length, which tells you the number of elements. And when you declare the array, you declare it like this with square brackets. After, and maybe even before. And then you create an array. An array is an object, so you create it with the new operator, and then the type and the number of values that you actually want in the array. Array variables don't care about how many elements. Array values do care. You can also initialize arrays like this, with this special notation. Once you have an array, or let's do this. So we have a variable, right? ARR. Oops. We don't have a variable ARR. Never mind. This thing appears to confuse this thing. So let me do this. what would this print? What's the length of this array?
5.
3, right? Because it has 3 elements. What are the numbers of those elements? They are elements 0, 1, and 2. We start at 0, right? And so I can also print something like this. So this would print 3, and then ARR of 0, which is 1. Does that idea make sense?
Do we have to import something for the arrays?
Nope. They are standard Java.
Can it be empty?
What do you mean by empty?
Like the array?
What do you mean by empty?
Like there is nothing in it, like 1, 2, and 3 pointed at it.
You could have 0 elements? Maybe. Let's see, does it work in this notation? Yeah, it does, right? Length is 0. Of course, this doesn't work anymore, right? Because there is no element number 0. But yes, you can have an array with 0 elements, which may not be what you mean by empty, right?
Like
Sorry?
an empty string?
The empty string has 0 elements. You could also have something like, there is different ways of what do you mean by empty, right? Sometimes people would say, okay, this is empty because it only has zeros, right? That's not empty. That's an array with how many elements? 4. They just all happen to be 0, right? Which would actually be the same if we do new ARR for new int. They get initialized to 0. Does this idea make sense? Yes. There are
So is it primitive?
Who is primitive?
Array?
The array is not a primitive. Int is a primitive, right? We could also have an array of person, right? What would this print? Still 4. What would this print? No, right? And so we could also initialize it. Could we initialize it to something like this? How do we create a person?
String,
New person, right?
first name.
It's 7, 11, something like that, right? When he starts. So now this would print what? 3. And this would print? Yeah, some version of Orlando Haram and 4E, right? Whatever our toString operator was. So this guy. Does this idea make sense? How do we print all the elements of an array? right? We'll see stuff that looks like this. Does this make sense? Do this. Make sense? Is this cool? That is basically all you can do with arrays. There is actually one slightly nice thing. You would think that a string is an array of characters. It is not. Java is sometimes idiotic. It would make sense, except that it's not. A string is actually a different class that's almost like an array of characters, but not quite. But we also have a special loop for arrays and other collections. Your variable now is the type of the elements, and you put a colon and then the array. And this will iterate and make p each one of the elements in the array inside the loop. So we'll just do system.out.println. Does this make sense? So this is basically equivalent to the other loop. We just print all the elements again. Which one is prettier? Which one do you like the best? Sorry? The first one?
The one you understand.
Which one is better, the first one or the second one?
The one you understand.
Sorry? The second one is new. Yeah. The first one should also be new now. Well, some of you already know loops, right? So the second one is arguably prettier, right? One possible problem is that it may be new for some of you, right? And the other one is not. The other thing is you also don't have the index, right? So for certain things, you have to do it with an explicit index. Sometimes you can get away with this kind of stuff, right? You could define stuff like so let me refactor this guy, make it, rename it, make it called people. I tend to use persons a lot. It's bad English, but it's good programming. How do we get whether an array contains an element? How can we do that? Yep, let's do it with this. I less than what? If I find it, what do I know? Does it contain it or not? Otherwise, Does this make sense? Do this. Just to leave it as an example. Let's do 10, 20, 30, 40, 50. Oops, we didn't make it static, so we can't call it. So this would print what? False and true. Couple of things. One of them, what is this guy? Now we know information, right? What is that guy? It's a static variable of the system class. Does that make sense? Just like we could have accessed book.numbooks, right? Numbooks. This is a static variable of the system class, right? There's another thing. What the heck is this? What is that? It's an array of strings, right? So we could print that array of strings. So let's create a function.
You said the string is not
Yes.
array.
Yes. What you're getting, if your main is an array of strings. Let's print it with this way. By default, you don't get anything. When you call a command, when you do stuff like git, whatever, these are the things that get passed as arguments. Does that idea make sense? ls a b c. This would be your args to your Java program.
Why is it a string?
What are these things? They're just bunches of characters, right? What else could they be, I guess? The most generic thing is just strings, right? And then you break it out, you could parse it as ints, you could do whatever you want. But there are ways that depend on your IDE of making it, but we can run it directly. CD, this is it, right? Yeah, I need to upload all this stuff, but build classes, and I'm here, so I can do Java ksu.cs this guy. It's dots. when you're running it, right? Because that's the name of the class. What? Pain. So I need to do one more. They are these guys. Does that idea make sense? So we have solved a couple of mysteries of Java. Right? Cool. We will go over this again on Wednesday. And we will have, and I will send an email right now, both assignments, whatever and whatever plus one, n and n plus one. 7 and 8, too. So good. They are super easy. They are almost as easy as 6. 6 was too easy, right? Almost. Cool. Then let's